So we are looking at finding the zeros in these functions like we've done in the past. So when you find the zeros, all you're doing is setting it equal to 0 and solving. So 0 equals negative 3x plus 2. And then we solve for 0, or for x. And so we get negative 2 is equal to negative 3x. Divide both sides by negative 3. And so 2/3 is equal to x. How do I solve the second equation? Because I'll set it equal to 0, but I can't isolate the x. I have an x squared there. What do I do to help get that to where I can isolate it? So we can solve it by either factoring it or using quadratic formula. And so if the a is prime, so in other words, we have a 1 in front of the x squared. That's prime. And the c is prime. It's often the best way, easiest way is to factor it. So when you use that box, the x squared goes here, the 2 goes here. And this is 2x squared, the product of those two, and negative 3x goes here. So what multiplies to give me 2x squared, but will add to give me a negative 3x? Those two numbers that can multiply to give me a positive 2. 1 and 2. And they both need to be negative if we want it to be a positive product. So negative 1x, negative 2x. So now I'm looking at factoring. The first column, what can I pull out of both of those? What's the same in both? They both have an x. And the second column, what can divide into both 1 and 2? Just a 1. And the closest sign is negative, so negative. So my first factor is x minus 1. My second factor, what can go into this first row?
X.
Okay. What can go into the second row?
Negative 2.
So that gives me my second parenthesis. Now all I do is set my parentheses equal to 0 and solve. Oops. So x equals 1 and x equals 2 are my two solutions. Now let's go on to 3. Question 3, I have x minus 2 and then parenthesis x squared minus 1. So I'm going to set it equal to 0. It's already semi-factored out, so I'm just going to set those factors equal to 0. As long as it's a binomial for both, you can usually do this. And so we have x is equal to 2. Well, x squared is equal to 1. So do I have it solved for x yet? No, you said? What do I need to do? How do I get rid of that squared?
Square root.
And remember, when you take a square root, the positive and negative goes in front of it. So these are my 3 solutions. So there's 3 different times that's going to cross the x-axis. So for today, what we're going to be doing is taking it from where does it cross the x-axis? Where are my zeros? and going back to the equation or going to the graph. And so we're going to be looking at cubic functions. So that means we're going to be looking at ones that have opposite directions on my ends. And we're going to find out different properties, and we're going to see what's similar and what's different. How do they compare and what makes them what they are? So on question 1, it says that we want to take and sketch one with the zeros at 0, 2, and 5. I want you to go ahead and perform that sketch. So when I sketched my graph, first thing I did is I put my zeros. And so my zeros were at x equals 0, 2, and -5. Now, it doesn't tell me any more information. So I don't know which way my graph's coming from, but I chose just to go ahead and do a basic positive one, positive A, which means my graph could look something like this. What are some things that are the same between my graph and your graph? Did we all go through the same x-intercepts?
Yes.
Okay. Did we all have 2 extrema? So we all went through the same x-intercepts. We all had 2 extrema. Did we all have our tails go opposite directions? Yeah. Did we all have all domain? Okay. Did we all cover all range? Yeah. Things that are different. You may have had different values. You may have had different max and mins, relative max and mins. You may have had different, meaning you could have gone up higher or lower in your hills and valleys. And you may have had a different A. You may have chosen A to be negative, and therefore it gone the opposite direction. So I want you to look at B. I want you to graph B. So this time we have some information that's a little bit different. It tells us we have a 0 at -3, and then at x equals 4 we have a multiplicity of 2. So what's going to be the difference between these two?
One of them is going to pass and the other one's going to bounce off of it.
This one's going to pass. This one's going to bounce. So at -3 we're just passing through, and at 4 we're bouncing off. Oops, let me go down far enough. So here's an example of a positive A version of that. You could have started up here and then bounced off and come back down. But similarities and differences are going to be the same thing. We're going to have the same, we have 2 extrema. We have, this time, only 2 x-intercepts. So our same, so we have the same number of x-intercepts. We have our tails going in opposite direction. We have covered all our range, all our x, all our domain. So those are all things that you need to list like we did last time. But what is different this time from the last problem? Did we go through both places? No. But if we were to compare between all of us in this room, we would have a very similar graph in the fact that we had both had a bounce there. They may be bouncing going down or bouncing going up, depending on what you chose for your A. So Derek and Alex disagree on which function, when multiplied together, would build a cubic function with zeros at 5 and -1, and -1 is going to have a multiplicity of 2, meaning it's going to bounce. So they both think these two spots are going to be affected. So this one is supposed to bounce, and that one's supposed to cross. Is this correct? Is one of them correct and one of them wrong? So let's go through it like we did back at the beginning of this chapter. We multiply. So on this side of it, we have a negative times a positive. So in that section, what would it be?
Negative.
Negative. Going to the right of it, we have a positive and a negative. So what's it going to be until I get to the next spot?
Negative.
And then now we have a positive and a positive. It's going to cross and go 3. Okay. So now let's look at to the left of that -3. Positive, negative, and then negative. What would that section be? A positive times 2 negatives.
Positive.
Positive. In this next section, we have a positive times 2 negatives, so it's a positive again. Let's see what happens when we get to this point. We have 2 positives and 1 negative, so what am I going to do next?
Negative.
Go negative. So did these both cross at x equals 5 and bounce at x equals -1?
Mm-hmm.
So are they both correct?
Yeah.
Yeah. They're both different ways you could follow it, fit the same set of rules. So you may want a calculator for this, because we're going to go through and I want you to graph each of these graphs. So in that top row, we had x equals, or f of x equals x. That's the first one. So that's just a linear graph going through the origin. Where would the next one go through? G of x. What's the y-intercept on that one? 1. And this point right here is the x-intercept would be -1. So here, what's our y-intercept?
-1.
And my slope is still +1. And then j of x, we have a +1 y-intercept. We go down with a negative slope. Make it a -1. So now let's look at the next one. For m of x is x squared. So that means it goes through the origin. It's going to curve both sides. Where does the p of x go through? What is the y-intercept on p of x? It's 1. It's always this number back here. and then it's going to curve out. On our next one, r of x is equal to x minus 1 squared. So that means I go right 1 and go through the origin, or go through the x-axis. And the last one, we have w of x is equal to negative x minus 1, x plus 1. And so that means we're going down with two intercepts, negative 1 and 1. Oops. Okay, now we're going to use this information to help us graph. And so if I want an imaginary 0, that means if I want something imaginary, what can it not do? Can't cross the x-axis. So which of these is going to give me an imaginary root? Well, this one right here isn't going to go through the x-axis. So p of x is one of my imaginary roots. Is there any other ones? So that gets care of my two imaginary roots. And a real 0, well, any real 0 is going to be this first row. And so depending on which one you chose, so let's say you chose x plus 1 and x squared plus 1 as the two things for your f of x. So that means at negative 1 I have a x-intercept, and at 1 I'm going to have a flattening point. So that means my graph is going to kind of curve up here, flatten out, and curve back out. So we're all going to have a vertical shift of 1. And then we're going to be all having just one x-intercept. I want y'all to do B, C, D, and E, and F. One of those is going to be not possible. And that's your homework. As we were looking, for the problems we were looking at, we were looking to see, we want it to have these characteristics. It has to be a cubic function. And we only have the functions up here. So if we want the y-intercept to be at negative 1, that means that we need to have all the different y values to multiply to negative 1. And so remember, this first row was all the ones that had a multiplicity of 1, or had 1, 0, and the second row is the ones that have 2 roots. And so our y-intercept needs to be we need to multiply it together and get negative 1. And so if we have this negative 1 times 1, that would work. Or 1 times negative 1 times 1. That would work. So you have a choice of which ones you want to use. You could use GHJ or P of X and H of X. And for me, I chose these three. And so that means this one has an x-intercept at -1, 1, and what is this x-intercept at? 1. So that means I'm touching and going back here, and I cross here. It goes through and it touches here. That is one of the graphs you could have drawn. So for our similarities and differences, we know that we all had a y-intercept at y equals -1. What other similarities did you have to mine? And y'all sketched y'all's. We should have all had the same number of zeros, because you couldn't have a 0 x at zeros. That means these guys were automatically thrown out. So we should have all had 2 zeros. What about your tails? Do they all go the same direction? Did you have everybody have it to where one's up and one's down? Did everybody go the same direction as me? Or did some of y'all go maybe this direction? So some of you may have had opposite on that one. Some of you may have had a different one where we touched and went back. So those are some things that could have been different than mine. On this next one, we have a 0 at x equals 1. And we want it to be a multiplicity of 3. So which of these graphs has a 0 at x equals 1? Oh, crud, undo. H of x does? Where else? We need to have 3, whether it's 1 or 3 from here or 1 from there and 2 from, and these have a 2. So we can do 1 and 1 or 3 from here. I did h of x and r of x. You could have also done j of x and r of x. So if you did, oops, that one, these two, your graph will look something like this. If you instead did these two, what would have been different is your graph would have gone the opposite direction. Oops. It would have gone. So what are some similarities and differences that we had? What are some similarities and differences between these two graphs? They both have the same 0. What else?
They end different, like they go different ways.
They're different because they go the opposite direction. What am I spelling? Cannot spell directions today. What else is different? Is there anything else? No? Pretty much this is the only difference is opposite direction, and then we have the same 0. What about if I wanted 3 distinct real zeros? So out of my graph up here, if we look, out of your choices, what are really the only 3 zeros we have?
The last one.
We have -1 and 1. What's another one we could have done? We need one more 0. F of x. So this is one way you could have gone about it. And if you did this way, your graph would have looked something along this lines. Another option you could have done would be this one. So what's different between those two?
I think it's just the same thing. They have the same zeros and it's a different direction.
Yeah, so it's the same as what we just said. So which quadrants are 1 and 3?
Is it this top box?
So this is quadrant 1.
Oh, it starts from
Yes, it goes, it's weird.
the, so then this bottom.
And so it goes this way to go around. So here's quadrant 3. It goes back to polar notation is where it goes to. And so it's all about physics on that part.
Well, that's something from here.
Well, I got it. It's too hard. Too much math.
And so those are quadrants 1 and 3, or physics and trig, excuse me. And so
Did we do a graph like the one we did above? 'Cause
this
if
one?
Yeah, if we flip it, because it'd be in those two quadrants.
Well, but it also has this quadrant and this quadrant involved.
What about C?
Very similar to C. What could we do with C to get it to where it's only, because this one touches here.
Put it at 0.
Put it at 0. So that would make it these two, because we wouldn't have a multiplicity of 3 at 0. And really, there's only, out of these options, there's only one way to graph it, was those.
How do you write 4 in Roman?
What?
How do you write 4 in Roman?
It's one,
But
D one or one B.
It's V1, and then 1B is 6, I think.
it's 1 and then V. If it's before, it lowers it. If it's after, it adds. So that's 4.
Quit.
No, because I'm just saying, never mind.
So we want to have 3 imaginary zeros. So imaginary means it doesn't cross the x-axis. So here is 2 imaginary zeros. I need to add 1 more. So which of these 3 graphs does not cross the x-axis?
The second one.
Oh, it touches it here.
Oh, crap. The one you circled.
The one I circled gives us 2. I need 1 more. And so the ones that give us 1 are this first row in blue.
F of X.
Well, it touches the x-axis here.
But none of them.
Then none of them. So it's impossible. So, what are the possible combination of real and imaginary zeros for a cubic function to have? So what is a possible, so let's think about it. So if you have a cubic, that means there needs to be a total of 3 zeros. So you could have 3 reals, right? I don't know why I wrote it that way. Because we were talking about Roman numerals earlier. And 0 imaginary.
2.
2 real. Can I have 1 imaginary?
Could it be in like the Y?
Mm-mm.
1 real.
1 real. 2 imaginary.
You have them all imaginary?
Because then we can't, because we looked at it and we couldn't see any way that we could have that 1 go through. So all imaginary sets need to have a set of 2. So like you could have 2, you could have 4, you could have 6, but if we're dealing with cubic, that means these guys are out, right? 0, 2, 6. A cubic function must have 3 zeros. From the fundamental theorem of algebra. However, the number of real and imaginary zeros can vary. A function may have 0, 1, 2, or 3 imaginary zeros. What is her error? It can have 0. Oh, did I go too fast?
Is that add or odd?
Odd. Augie, Catherine, and Chili each wrote a cubic function with the zeros at x equals 3, x equals 1, and x equals -4. Augie's was f of x equals x minus 3, x minus 1, x plus 4. It has the 3 zeros, and you can check it by setting those equal to 0, and it's solved. Catherine had the same thing, except for she put a 5 in front of it all. And Chili had 2x minus 6 at times 3x minus 3 times x plus 4. And it has those 3 zeros. And so we're going to look and see they're all 3 right. Why does multiplying by that constant, how does multiplying by that constant affect the graph? So I want you to go ahead and graph those 3 and see if you can answer question 8. You may want to adjust your window. You know we need to be between -4 and +3. And so I'm going to go ahead and change my x-axis from -5 to +5, just kind of give it zoomed in there. And for my y-axis, I went from -50 to +50, just to give me some room for the way that things look on the graph. So here is Augie's graph. Would I do the same thing, but with a 5 in front of it? What did y'all see it happen to the graph?
It just changed the shape.
Change the shape. How did it change the shape?
Like it went up higher and got skinnier when it went down.
So it stretched it up and down, right? So we had a we basically pulled it apart vertically, right? That's what that constant did. So let's see if that holds true for when we do Chili's. So we didn't have a constant in Chili's, right? How come did it stretch it more?
Because the 2 and the 3 were on the inside of the parentheses.
Oh, okay. So we had it, we just had it in a different way. So this is the same thing as me saying 2x minus 3 times 3x minus 1 times x plus 4. And so if I was to combine the coefficients, that'd be 6, x minus 3, x minus 1, x plus 4. So that 6 was bigger than the 5, so it stretched it more. Okay? So we said that it gave us a vertical stretch. So why do you think the zeros remain the same after that multiplying by constant?
It's not doing anything to the zeros, it's just stretching it.
It's just stretching. How many different cubic functions can you write if you're given a set of zeros? Infinite. Because there's an infinite number of coefficients you could use. What do you think would happen if my coefficient was, instead of being 5, being 1/5?
It'll vertically compress.
Okay, let's see. Oops, 5, that's what I said. Did it vertically compress it? Okay. So I want y'all to think of 2 different cubic functions with these different characteristics. So if we know the zeros, let's go ahead and find the factor. what factor would x equals 2 have?
X minus
What factor would x equals 0 have?
2. X.
Equals 0.
So this is going to create the x minus 2. This is going to create the x. What would x minus 4 create?
Equals 4.
So those are the three factors we have to work with. And I want you to come up with two different cubic functions. So the equation I came up with, one of the equations, so what do you think that negative is going to do? Flip it. It's going to go the opposite direction. That 3 is going to stretch it out. Another one I came up with was just the basic one. And for lack of a better name, it's like the parent function of the set. You could have come up with different ones. I want y'all to go through, oh, actually, I need to go through this one with you. So if x equals 0, that's just going to give you that factor of x. X equals 2i gives us a factor of x minus 2i. X equals negative 2i gives us a factor of x plus 2i. This is not something that we're familiar with working with, so we need to multiply that out. X minus 2i, x plus 2i, so it gives you I squared, negative 2i x, positive 2i x, and negative 2 times negative 2 gives me a negative 4i squared. What does I squared become?
0.
Not 0,
Well, it doesn't
Negative
because
1.
it just.
negative 1. Are you talking about these two?
Yeah.
Okay, those two do cancel out. The I squared becomes negative 1. So 4 times negative 1 means that section is now a positive 4. So this factor here is x squared plus 4 when combined. And so my basic function of this is x times x squared plus 4. Now I'll come with one other one. Anybody give me their other function?
Two x, and then parentheses 2x squared plus 8.
That's another one. So now go through the other ones and find. So when it says a multiplicity of 2, that means the exponent's 2. So you go through and you find the factors the same way. You just put an exponent of 2 on the one that's a multiplicity of 2. So what's another function you could have written? Anybody give me another one? What about 2 in front of it? plus. So that's another function. Any other coefficient would work, or if you multiplied a 2 through one of these two parentheses. Or something else through one of those parentheses. Or put a negative in front.
Why would you still have to square if you're already multiplying into?
The 2 is not a squaring, it's not the same thing. I could have put this number as any number. It's just a coefficient. So whatever coefficient number you want to write there.
So it's like just making it different from the first one?
Yes. So for this next one, we had to think a little bit further. Because it says it wants to have a y-intercept at y equals negative 24. So we need to find all three y-intercepts of what we have, multiply them together, plus whatever we want to have as a coefficient, or as well as what we have as a coefficient, and solve. And so that tells us our basic one. This is going to become that coefficient. Now, anybody come up with a second one? As long as you put two negatives involved with it. So I multiplied this by negative and that by negative. Or you could have done something as simple as oh, that's supposed to be a 1. So those would all be 0. All be a different way of writing it. I want you to think through on the talk and complete each statement with always, sometimes, or never.